NASA is flying toward an asteroid that has been called the most valuable object ever discovered. 16 Psyche has been assigned a theoretical value of nearly $10 quintillion, a number so enormous that it is almost impossible to imagine. But that headline hides the real mystery, because the closer scientists look at Psyche, the less certain they become that it is the solid metal world everyone once imagined. NASA's Psyche mission is not traveling toward a simple mountain of iron, floating through space. It is approaching an object that may itself be the remains of a destroyed world, or something planetary science has never encountered before. So what exactly will NASA find when it reaches Psyche in 2029? When 16 Psyche was discovered in 1852, it appeared to be just another object orbiting in the main asteroid belt between Mars and Jupiter. But over time, observations revealed that Psyche was unlike almost anything else in the solar system. Radar measurements showed unusually strong reflections from its surface, suggesting the presence of metal-rich material. Spectral observations also pointed toward iron-bearing minerals, leading scientists to consider a remarkable possibility. Psyche might not be an ordinary asteroid. It might be the exposed heart of an ancient world. More than 4 billion years ago, while the solar system was still forming, young planetary bodies collided repeatedly. Scientists proposed that one of those early worlds may have suffered a series of catastrophic impacts that stripped away much of its rocky exterior, leaving part of its metallic interior exposed. Psyche could be a surviving fragment of that lost world, and its scale makes the possibility even more extraordinary. Psyche is irregularly shaped, measuring roughly 280 kilometers at its widest point, comparable to the straight-line distance between Los Angeles and San Diego. The famous $10 quintillion estimate came from applying modern Earth-based metal prices to Psyche's possible iron and nickel content. But that number was never a realistic treasure calculation. Those metals cannot simply be transported to Earth and sold at today's prices. And if an enormous new supply ever entered the economy, the market that created the valuation would change. The $10 quintillion figure exists only on paper. The scientific question behind it is far more important, because if Psyche really is the exposed core of a destroyed world, it should behave like one, and that assumption was about to be challenged. The first major problem came from one simple measurement: density. Scientists cannot place Psyche on a scale. Instead, they estimate its mass by measuring how its gravity affects nearby objects. They then compare that mass with observations of the asteroid's size and shape. Together, those measurements reveal its average density, and the result was unexpected. A solid iron-nickel core should be extremely dense, but estimates place Psyche's density at roughly 3.4 to 4.1 grams per cubic centimeter, far below what scientists would expect from a compact body made mostly of solid metal. Psyche was not matching the simplest version of the exposed core theory. Its interior could contain large amounts of rock mixed with metal, deep fractures created by billions of years of impacts, or a structure far more complicated than the original model predicted. Lindy Elkins-Tanton, principal investigator of NASA's Psyche mission at Arizona State University, has described the mission as an opportunity to examine a kind of world humanity has never explored up close. That uncertainty is precisely why the mission exists. Psyche was still clearly unusual, but the density problem suggested that the original story was incomplete, and it was not the only observation that refused to fit. The first layer of evidence still supports the idea that Psyche is a metal-rich world. From Earth, scientists have studied how light and radar waves interact with its surface. Radar is particularly useful because metal-rich material can produce strong radar reflections. Psyche's radar characteristics indicate that substantial amounts of metal are probably present near the surface. Other observations, however, also reveal silicate minerals, the kinds of rocky material found throughout the crusts and mantles of planetary bodies. Psyche does not appear to be pure metal. NASA estimates that metal may account for roughly 30 to 60% of its volume, with the rest likely consisting of rocky material and possibly empty spaces. From a distance, Psyche could still resemble the exposed heart of a planet, but radar and reflected light reveal only part of the story. The density problem raised the possibility that its interior is fractured, porous, or thoroughly mixed with rock. Instead of a solid planetary heart, Psyche may be a metal-rich ruin, the remains of a body repeatedly broken and reshaped by collisions. Then researchers found an even stranger clue on the surface. Observations at visible, radar, and infrared wavelengths already suggested that Psyche contains a mixture of metallic and silicate material. Additional studies around the 3-micron region of the infrared spectrum detected a weak absorption feature consistent with hydroxyl or hydrated minerals. The interpretation remains uncertain. The signal does not necessarily indicate liquid water or exposed water ice. It is more likely connected to hydroxyl bearing or hydrated compounds present in portions of the surface. But that raised a difficult question. If Psyche is the exposed metallic interior of an ancient planetary body, how did hydrated material reach its surface? One possibility is that water-rich carbonaceous asteroids struck Psyche over billions of years and deposited foreign material across parts of it. Another is that Psyche's original formation was far more complicated than scientists first assumed. Perhaps it was never a completely separated metallic core. It may be a partially differentiated body in which metal and rock never separated cleanly, or repeated impacts may have stripped, mixed, shattered, and reassembled its material over time. None of these explanations has been confirmed. The exposed core theory may not be entirely wrong, but it may be far too simple. Psyche may not be the untouched heart of a planet. It may be the battered aftermath of how worlds are built, torn apart, and remade. For Lindy Elkins Tanton and the team behind the Psyche mission, that uncertainty is not a problem to eliminate before the journey. It is the reason to go. The spacecraft launched in October 2023 and completed a successful gravity assist flyby of Mars in May 2026. Mars increased its speed and adjusted its trajectory, placing it on course to reach Psyche in the summer of 2029. For years, the asteroid has existed for the mission team only as radar echoes, spectral measurements, mathematical models, and a tiny point of light moving through the asteroid belt. When the first detailed images arrive, an object they have spent much of their careers imagining, will finally become a real landscape. The arrival will not be the confirmation of a treasure map. It will be humanity's first close examination of a metal-rich world unlike any object previously explored by spacecraft. The spacecraft's multispectral images will photograph the surface and help distinguish major geological materials. Its gamma-ray and neutron spectrometer will measure the chemical elements present near the surface. By tracking tiny changes in the spacecraft's radio signal, scientists will map Psyche's gravity and determine how mass is distributed inside it. And the magnetometer will search for evidence of an ancient magnetic field. If Psyche preserves fossil magnetism, it would be strong evidence that its material once belonged to a molten, differentiated planetary body. The reason this matters reaches far beyond one asteroid. Earth's metallic core lies thousands of kilometers beneath our feet, beyond the reach of any drill. Psyche may offer scientists a rare opportunity to study materials and processes associated with planetary interiors without cutting through an entire planet to reach them. NASA is not approaching a cosmic vault of wealth. It may be approaching a surviving fragment of the process that created worlds like our own. When the spacecraft enters orbit around Psyche, scientists will finally begin testing questions that cannot be answered from Earth. Is Psyche part of the exposed core of a destroyed planetary building block? How much of it is metal and how much is rock, fractures, or empty space? And does it preserve magnetic evidence of a once molten interior? Planetary exploration has overturned simple assumptions before. During its journey to Jupiter, NASA's Galileo spacecraft photographed the asteroid Ida and discovered something no one had known was there: a tiny moon, later named Dactyl, the first confirmed moon found orbiting an asteroid. From Earth, Ida had appeared to be a solitary object. Up close, it became a miniature system. Psyche may hold the same kind of surprise. The $10 quintillion asteroid was never really a story about money. That number came from imagining what Psyche's metals might be worth on Earth. But its true value lies somewhere else. Inside Psyche may be clues to how planets form, how worlds are torn apart, and how Earth developed the metallic core hidden beneath our feet. The greatest treasure in the solar system may not be something we can mine. It may be something we can finally understand.